Okay, so here we have chapter 9, which is with polar coordinates and the complex numbers. So the first section is just deals with polar coordinates. So objectives for this section: graph points and polar coordinates, graph simple polar equations, and then determine the distance between 2 points with polar coordinates. So in the polar coordinate system, you have a fixed point O. That's called the pole. It's the same thing as the origin on the xy axis. And the polar axis is a ray that runs from the origin and points to the right, away from the pole. So if you think about the picture, like it just looks like just an arrow pointing right. So there's the origin O. The pole points to the right, so it's at 0 degrees. Right. The location P in the polar coordinate system is identified by an ordered pair that looks like this: r comma theta. R is the radius, and theta is the angle at which the coordinate sits. So a couple examples here. So graph each point. So the first point, we'll call this one actually P1 and P2 since I have 2 P's. So P1 sits at 3 comma 60 degrees. So 3 is the radius, it's how far out from the center you go. And the 60 degrees is the angle, the ray, that that point sits on. So normally you actually use the ray first. So you'll find 60 degrees, which is this ray right here. And then from the origin, go out, let's see here, 1, 2, 3 rings, and put your point. So there's P1 right there. So for P2, that point is given to you in terms of radians, so you may need to convert that to degrees. The first value is still the radius r. So 7 pi over 6, so to remember to convert to radians, you're going to multiply by 180 and divide by pi. So this is 7 pi over 6 times 180 over pi. So this is the same thing as 210 degrees. So I'm going to find my 210 degree ray, which is right here. There's 210. And then on that ray, I'm going to go negative 1.5. Now here's the problem. So 210 points this way, down to the left. So the negative 1.5, I'm actually having to go backwards, which is on the same ray as the 30 degree ray. So I'm going to go 1.5, about right there. So there's P2. Since that's negative, I went away from my 210 degree ray. So point R has both a negative radius and a negative angle. So I'm going to make this a positive angle by adding 360. So that's the same thing as 225 degrees. So I'm going to find my 225, which is right here. And I have to go backwards 2. So 225 carries on backwards, and it is the same thing as the 45. So backwards 2, be actually that point right there. So R. So that one's R, that one's P2, that one is P1. So that's plotting the points. Okay, you can actually have an equation as well. It's just called the polar equation. The polar graph is a set of all the points whose coordinates r theta satisfy the equation. So just like a y equals equation is the line it draws is the set of all points that satisfy y equals whatever function of x it is. So there's 2 general forms. The very basic ones, you can have an r equals or you can have a theta equals. R equals equations will always draw circles because all this says is that the radius has to be 3 units. So I'm going to go, oops, so here's the r, it's labeled actually as 3. So r equals 3 is that equation. That's r equals 3, the ring. Theta, I'll turn that into degrees, so multiply by 180, divide by pi. That's 135, is a line. So this one draws a circle. This will draw a line. The line just has to pass through 135 degrees, so you find 135, which looks like it's right here. And you start on the edge and then go back through the origin. And then you come out the other side. It's kind of hard to tell which one it is. It's going to be 315. So that's the line. Theta equals 3 pi over 4. Okay, the last one for this section, you've got the distance between 2 points. That's a little bit different than the with Cartesian. So you have P1 that sits at R1 theta 1 and P2 that sits at R2 theta 2. Then here is your equation. I didn't really work an example, but we can make one up. So say you had 2 comma 30 degrees and 4 comma 15 degrees. So the equation is going to be the distance between P1 and P2 is equal to the square root. So R1 squared is going to be 2 squared plus R2 squared is 4 squared. 2 times R1 times R2 times the cosine of the difference of the angles, theta 2 minus theta 1, so 15 minus 30. So if you type this all in, 2 squared plus 4 squared minus 2 times 4 times the cosine of 15 minus 30. Make sure your calculator for this problem at least is in degrees, since your angles are given in degrees. So the stuff underneath the square root is 0.54, just like that. So if you take the square root, you'll get 2.1. So they're 2.1 units apart. So that's the end of section 2, or 9.1.